All right, well, good afternoon, everyone. Thank you so much for coming back to the Barrel Lodge here in the AMK Ranch. I'm Bryan Shuman. I'm the current director of the UW-NPS research station here. And it's been a long journey over the last couple of years of getting renovated and getting through COVID. And thank you to all who joined us last year for the few events we did in Jackson. But we're so excited to be back here in at the Barrel Lodge and at the AMK Ranch. So we wanted to do this event today in part just to kind of kickstart our new era of having some renovated facilities up here. But also we have a big new research initiative that we're going to be starting and launching here, thinking about the future of this landscape and how it changes. And so I want to take this opportunity to talk to you about that and kind of think a bit with you about how might the Tetons change as we look ahead to the future here. So and just to introduce myself a little bit more, just for those of you who don't know me, I'm a professor at the University of Wyoming in the Department of Geology and Geophysics. I'm also part of our program in ecology. And so I have and our program in hydrology, actually. So I have a broad interdisciplinary interest in environmental sciences. And it's been my real pleasure to work with a wide range of different researchers who've been invested and involved up here. But my particular specialty is actually thinking about climate change. And so that's where the angle I'm going to take for the presentation today. Here we go. So a few years ago, we did a strategic planning initiative for the AMK, for the UW-NPS research station. And we really wanted to think more about who are we and where are we headed as we look to the future. So this talk, while I'm thinking about how do we envision the future of the Tetons, it's actually tied in parallel to our process of thinking about the future of our research station. And one of the things that we decided was a really central goal for us was thinking about how do we enhance the ability of the University of Wyoming to play a role in informed stewardship of these iconic landscapes all around us. And we had a great discussion on campus and involving people up here and elsewhere that helped us think about what are some directions that we might go. And a major theme that emerged from that discussion, that strategic planning initiative, was thinking about how do we as a university and here as a research station help communities around us and just the general, the state and the nation even think about how do we anticipate and respond to the climate transition that is upon us. Climate here is changing, it's impacting these wonderful places that we live and we all love, but it's also impacting us in ways that impact our lives. And so how do we as an institution help prepare people and anticipate those changes and think about how do we be most resilient to them? So we worked as a large group of faculty across the campus of the University of Wyoming and applied to the National Science Foundation through a program known as EPSCoR, which is the existing program for stimulating competitive research, which is or established program for stimulating competitive research. And through this, they fund particularly large interdisciplinary statewide programs. And so we were fortunate to be funded for the next 5 years at a $20 million level to run a program that we call WyACT. And the WyACT project is really, the heart of it is going to be aimed at thinking about how do we anticipate the climate transitions ahead. And that's what WyACT stands for, Wyoming Anticipating the Climate Transitions. And at the university, this involves a team of about 20 different researchers who span from atmospheric sciences to hydrology to ecology to economics and social sciences, a very broad range of different topics. We also involve people from the journalism program, from our education program. And one of the goals is for us not to just sit back at the university or come up here and do our research, but to actually work with people across the state. And here, in particular, to work with people in the park, in the adjacent communities, and also just general people from the public who are interested and love this landscape. We want to work with you to help us let us help you think about how is this place going to change and what do we need to do to prepare for those changes. To be, I think, a major theme for a lot of the research that might move forward here through the research station in coming years, in part stimulated by this grant, but in part because that grant captures the direction a lot of research is headed. We know these changes are upon us and we have to prepare for them. So I sort of like to synthesize this whole issue as, take this fantastic photo by Ansel Adams from 1942 of the Grand and the Snake River. And in many ways, you look at this photo and it doesn't seem that different from the way it would look today. This is such a healthy, amazing ecosystem right now, and yet we know it's poised for changes. And so the part that's so hard to get our fingers around is how is this going to change? How is that picture going to change as we move forward into the future? And what are the consequences of those changes that will impact us and the region, our communities? What are the various things that we need to prepare for? And so this is, I want to give you a bit of a perspective today on what some of those changes might involve, and then sort of show you where we're headed in terms of thinking about how we might think and study, prepare for these consequences. One of the reasons it's so exciting to work here on this topic is that it's not just, we can work here and we can study this amazing, iconic place and how it's changing, but the wonderful thing about working here is it's also connected to so many other places. So if you take water, for example, here we are in the Tetons at the head of the Snake River, but not very far away is the head of the Missouri and Mississippi River system, and not very far away is the headwaters of the Colorado River system, the three biggest river systems in the West that are so important to the water supply of the Western United States. So what changes here have consequences that extend far beyond this location. So this is a chance to study things that happen here, but also that cross boundaries and have farther reaching consequences. And it's not just the physical science things like water, it's also things like wildlife. Many of you know about these incredible animal migrations of, say, the mule deer that migrate from down near Rock Springs in southern Wyoming all the way up right through the ranch here and head on up into Idaho. How will those types of connections across this whole landscape be impacted by the changing climate? And a big part of our project, we will be interested in how the aquatic ecology is impacted. If you change the water, what's that going to do to our cutthroat trout populations? These are things that are deeply important to many people, but we care about it also just from the sense of the health of the ecosystem. And if you impact the trout, then you potentially impact the tourism here. This has impacts that then extend in that direction as well. So we think about this again as if we study this location, we're studying a really important nexus where the environmental change interfaces with societal values and economic impacts in ways that then ripple across not just Teton County and Grand Teton National Park, but connect to all the towns that people drive through on their way here. So it's part of our goal here is thinking about the changes and thinking about how they connect to these processes and phenomena that cross boundaries. The hardest part of looking ahead and thinking about all these things that might be affected by climate change as we look into the future is that the greatest uncertainty isn't necessarily about the specifics of how the climate will change. A lot of that is fairly well constrained by the physics of the system. The greatest uncertainty really relates to our own decisions. And so this graph is just sort of to represent that point, that this graph here shows from 1900 up to the 2100, the potential concentrations of carbon dioxide in the atmosphere. And so we have, over the last century, raised the concentration of carbon dioxide quite substantially, so that if I took 1 million molecules here in front of me, 300 of them would have been CO2 about 100 years ago, and now over 400 of them would be CO2. That doesn't seem like very much, but it has a tremendous impact on our Earth system if that change occurs. And as we look forward to the future, the hardest part about knowing what's going to happen is knowing how much more carbon are we going to put into the atmosphere. So I'm going to show you some results from the Greater Yellowstone Climate Assessment that I was fortunate to be a co-author part of over the last few years. And I'll connect some of the rest of the presentation here to that. But in the context of that, I'm going to focus on two possible scenarios for the future. One, which is represented by this blue line here, where we continue to add carbon to the atmosphere, but eventually that settles down sometime in the near decades. And so we reach a sort of steady, stable position in terms of the climate. And the alternative is a place where we have really no mitigation of that CO2 into the atmosphere. And we just continue to add CO2 until it gets to much, much higher levels than we currently face. And they become geologically high, even in the context of all of Earth history. So I'll just show you these as some of the choices that we face, and then we can think about how they might have different consequences for us. So here's just a simulation of future temperatures for this region, for the greater Yellowstone region, based on those two scenarios. One is the blue, where we mitigate some of the carbon emissions and stabilize it by mid-century. And the red is where we have no mitigation at all. And if you look at the graph here, it goes from 1900 again to 2100. This is just degrees Fahrenheit departure from the average for the 20th century. And the black line here is the observed temperatures over that time period. And you can see most of the time temperatures where you can kind of roll the dice, you're getting slightly higher or slightly colder years. But in recent decades, we've started to roll the dice in a way we find that the dice are loaded by that additional CO2 in the atmosphere. We're more consistently getting warm years. But this is just the beginning of a change that, if you look at the projections here, extends way out into the future. And in a scenario where we have some mitigation of carbon, the temperatures here, the average temperature per year rises a little, somewhere between 7 and 8 degrees Fahrenheit. If we don't have any mitigation of carbon in the atmosphere, we end up raising temperatures here by at least about 12 degrees by the end of the century. And this seems a bit abstract, I always think, but these are actually two really very, very different outcomes. And so we have a tremendous amount of choice before us in terms of how dramatically are the changes going to affect us. But I want to give you some context for these numbers so that it's not just 7 degrees or 12 degrees. That it's a little bit hard to know what does that really mean. And I actually think if you look out the window here and look at the mountains, this is a great place to think about these numbers, because we can actually put them in a really specific context of the glacial history of the Tetons. So if you look out and you look at where the glaciers had come down out of the canyons in the mountains, Jenny Lake was carved by this big ice sheet coming down out from behind through the canyon there. Those glaciers that formed those lakes and formed those moraines and formed those canyons, they were formed in a world that was about 5 to 7 degrees colder Fahrenheit on average than today. So when we're talking about warming by the end of the century, that's say 7 degrees warmer or 12 degrees warmer, we're talking about changes that are on the same magnitude as the amount of warming that melted away all these glaciers and transformed this landscape from one that was totally ice covered to one that's the canyons and forests and lakes that we're used to today. Just to give you a different picture of this, I did a little schematic here. If you can imagine this, here's the glaciers coming down out of the canyons, and 5 to 7 degrees of warming melted those away, allowed the forests to move in. And I always think this is so fascinating when you're out there and walking around like Taggart Lake or around Jenny Lake, you're walking on these moraines. If you go up in the canyons, these U-shaped valleys, these are the ruins of this colder climate, this colder world. And I often say to people, you can go to Athens and stand on the ruins of an ancient civilization. Here, you're coming and standing on the ruins of a colder world. And the difference between that world and today is roughly equivalent to the amount of warming we might expect if we mitigate some of the emissions into the atmosphere, stabilize our temperature later in this century. If we don't mitigate that, and we really end up with a lot more carbon being added to the atmosphere, we end up with warming that's almost twice the magnitude of the difference between now and the last ice age. And that is a huge, huge difference. And so I think it's really worth us keeping in mind, we're not just talking about it's going to be slightly warmer and there'll be more forest fires. we're potentially talking about fundamental transformations of the ecosystems that we're used to. And that's at the heart of our project here, is to help us all think about that and grapple with what would that mean. And just one point I want to make here is that there's one more important difference between these two scenarios. If you look at when we reach an ice age level warming, if we don't mitigate carbon in the atmosphere, we reach that ice age level warming sometime mid-century potentially. But if we mitigate carbon in the atmosphere, we actually have another 50 years or so before we reach that level. So it's not just the magnitude of change that's important, it's actually how much time we have to adapt and prepare for it. And so that's also at the heart of the issue, is how are we going to prepare for those rates of change, and how much time do we have to respond to that? I'll give you one more picture of that ice age world. I showed you kind of locally the Tetons here, but I think it's sometimes valuable to see it at the continental scale. I'm a geologist, so I have to tell you about the past. Here's a map of North America from 21,000 years ago. Here's the extent of the ice sheet that covered all of Canada. It went down to Des Moines, went down to New York City. And if you look at this map, you can see a fundamentally different world than the one we live in, this huge, huge ice cap. But also the green is showing where there's fossil evidence of forests, of spruce forests, like the boreal forests that we have up in Alaska and all the way across to Quebec today. They formerly grew in places like Alabama and Tennessee. And if you look at the coastline here, it looks kind of a bit cartoonish, but that's because sea level was about 300 feet lower, and all that water was trapped in the ice. So what I'll show you here is a little animation that just shows the transformation that took place for North America because of that 5 to 7 degrees of warming. And to me, this is what I ground my own understanding of climate change in, is realizing that that amount of global change in the past raised sea levels, shifted our ecosystems dramatically. Take this belt of green forest from Tennessee all the way up to the Arctic, and melted away this tremendous ice sheet. So it's not just transforming local places like here, but it totally affected the whole continent. And so that's, when we talk about, say, 7 degrees of warming, that's the scale of consequence that can be useful. I often keep in my mind. So just to go back to Ansel Adams' photo here, our choices are going to be key to determining the outcomes. And it's both the choices as to how much carbon we put in the atmosphere, but also how much do we prepare for those changes. And it's worth keeping in mind that some of those changes could be quite large. If you look at this landscape, it's a place where we can see the magnitude of change that's happened on that scale in the past. So I'll shift gears here just to talk a little bit about, we're at the beginning of these changes, so what is actually changing already here? And just to give you a couple kind of key bullet points, and if you didn't get one, there's postcards out on the table out there that summarize some of these key points from our Greater Yellowstone Climate Assessment report that we published last year. Since 1950, this region has warmed by about 2.3 degrees Fahrenheit. This is the average across the whole Greater Yellowstone region. So we see this warming, and what's really happened in many ways is not necessarily that we have unusually warm temperatures, but we've really lost the cold years. That so far is the biggest transformation, is that we're losing the really extreme cold. And we have not really had a significantly cold year since Mount Pinatubo erupted back in the early 90s and actually caused some global cooling from that volcanic eruption. That's the last truly cold winter we've had in this region. As a consequence of this, our snowfall has also changed dramatically. Total precipitation hasn't changed on average, but the snowfall, which on average across the whole Greater Yellowstone region is about 100 inches per year, has declined about 24 inches. So since 1950, we've lost about 25% of our winter snowfall below. This is for locations where we have weather stations, which are mostly below about 8,000 feet. So I'm not talking about like up high in the mountains. There's actually some evidence that some of the really high elevations have actually gone the opposite direction and seen more snowfall. But for most of the lower elevation areas, which is where most of the snow actually does fall, we've had about a 25% loss, 24 inches here. And so if you put those two things together, you make it warmer, you have less snow, this affects when that snow melts off early in the spring. And so the timing of peak river flow has shifted over this time period by about 8 days. So since 1950, it's really variable year to year, of course, but since 1950, the peak runoff down the Snake River and others is shifted by about a week. And it's different, it varies depending on where you are across this region, which streams and rivers you're talking about. But if you're looking at the ones that are not managed, they're the kind of free to flow and following just what the snowpack is doing, they've shifted by about 8 days.
Shifted earlier?
Earlier, yes, good point. Yeah, so it used to be that peak runoff would be mid-June, about June 14th, and now it's the first week of June. And another piece of the precipitation story is actually that not only are we losing the snow, but we're also changing the timing during the year when the precipitation comes. So this bar chart here is showing you the average change in terms of inches of precipitation for each month. So January all the way through December here. And the main thing to notice is that there's like bars going down here for the winter months, bars going down for the summer months. So if you just looked at winter and summer, we've seen this reduction. But we actually see an increase in precipitation in spring and fall that's kind of offset those winter and summer changes. And so there's actually one of the big things that may be important for our ecosystems and how we use water here is that it's shifted the timing. So springs are wetter, you're melting the snow sooner and you're getting more precipitation. So in some ways, it's not surprising we have greater flood risk in the spring. And at the same time, in the summer, we're getting less precipitation and all that snow melt went out of the system earlier, so we have greater drought risk later in the year. So and in fact, we see that in the river gauges. And here I just put up the Yellowstone River gauge just because we had that terrible event earlier this spring with the flooding up on the Yellowstone River. But this is the pattern since if you compare the kind of mid to late 20th century with the last 30 years or so, these are the percent change in river flow for two different locations on the Yellowstone River. There's less flow most months, but there's more flow in the spring months. So May and June, lower down on the river and, higher up on the river and, lower down the river and March, April, and May, lower down. So, but then all that water flushes out of the system. And so then through the summer months, we have extended lower water levels than we've had in the past. And this has consequences for things like the trout fisheries because now you have lower water that can warm more rapidly. So those are the changes that are already here. These are not things that we're projecting. These are the trends that are already underway. And so we can expect many of those trends to project out to the future. And what our project is aimed to do is really help us think about those projections and take them further, and actually also help us think about how do we know that? How do we trust these projections? So one of the big goals of our project, and what we're going to try to do here through the AMK Ranch at the research station, is think beyond just our field research. We want to connect our observations, our studies here of the lake, of the forests, of the streams, of the trout, all the things that are up here. We want to connect that field research with our ability to now use supercomputers and other computational techniques to do simulations and modeling to think about the future. And so we think about this as a project that's going to take classes of students and our own researchers, have them up here doing field research at the station, but also working at through resources like the NCAR Wyoming Supercomputer Center outside of Cheyenne. And then we also want to take all of that research and link it with discussions like we're having now, where it's not just us off at the university thinking by ourselves, but actually having conversations with all of you about what really matters, what are some of the assumptions we're making, what are some of the important consequences that you're concerned about, so we can make these projections, we can inform them with our field research, we can make them in more sophisticated ways using the computer resources, but we can ground them in the reality through our discussions with all of you. And we hope that we can make the research really meaningful and useful to you. So just to shift gears to thinking about, okay, how do we take those computer resources and simulate the future? I just want to show you some of the simulated results that we did do for the Greater Yellowstone Climate Assessment, and keep them in your mind as you think about, how does this really matter to you? How is this going to matter to the ecosystem that you care about? What are some of the decisions you might be making about a business or anything here? That where this might come into play, because we would love to hear those concerns and thoughts and help target our research accordingly. So I'd like to go back to that graph of these two scenarios looking to the future where things warm by an ice age or more worth of warming, and think like, what are the local concerns that we face there? So another way to look at these numbers of 7 to say 12 degrees of warming is to think about it in terms of things that we feel a little bit more regularly. We don't feel like really think or experience average temperatures very well, of course. But you might think like, well, how often do you experience a day with average temperatures below 32 degrees Fahrenheit? How often is it below freezing? And for Jackson now, it's pretty typically about 250 days a year. It's Wyoming. You guys, it's pretty warm up here compared to Laramie. But 250 days out of the year are below freezing. But in those two scenarios, those choices we have looking to the future, with some mitigation, that drops down to about 200 days below freezing. So 50, almost 2 months less of freezing weather by the end of the century. And if you go to the scenario where there's no mitigation, it gets down to about 150 days per year below freezing. That's a pretty substantial change in like our growing season, our fire season, things like that would be really impacted by this. The other side of this, the one that I find most striking, is thinking about the number of days above 90 degrees Fahrenheit. So that's very rare now up here, but on these two emissions scenarios looking to the future, with some mitigation, we can keep it down to where this gets to be a place that has about 2 weeks per year of 90-degree weather. But with no mitigation, we keep adding CO2 to the atmosphere. The simulations suggest that we end up with 60 plus days per year of 90-degree weather. So imagine this region with 2 months of 90-degree weather. It's just a fundamentally different ecosystem, a fundamentally different place to be. So temperatures are one thing, but the big concern that we're really interested in, well, a major concern, the one we've heard already from interviews we've done with people across the region, all of you, we all know water is a major concern. I mean, here's a photo I've been showing you repeatedly of the lake. And of course, if you go and stand down where this photo was taken, this is not what it looks like right now. The lake is 30 plus feet lower because of the need in Idaho for that water. So water is such a huge concern. And just the thing that I thought was most striking when we looked at these simulations about how the future changes here is the impact on our snow. That's the source of our water. And this rectangle here is a map of the Greater Yellowstone region. So that black outline is the outline of the Greater Yellowstone ecosystem. The thin black lines here are the watershed boundaries. So we're located right here. This is the Tetons here. We're right up in this area. The blue is where most of the precipitation, all of the precipitation, falls in the winter months as snow. And so it's all the high elevation areas where the snow accumulates. And the different red and green shades are places where you get some mix of rain and snow. But if we look at this same map, this is kind of the average conditions from 1986 to 2005. This is kind of the average, you can think of the blue here as the average extent of winter snowpack. If we look towards the future, this is starting to change. So in the current decade, it's not tremendously different from where it was before. But as we go out to later decades, that blue area just starts to disappear. And so imagine this region, instead of being one that's totally dominated by snowfall for a huge snowpack, but one where that snowpack is really limited to the high elevations. Again, this is a fundamental change to where we are. And this is at the heart of our project, the WyACT project of Wyoming Anticipating Climate Transitions. We're talking about this transition from snow to rain, and thinking about what are all the consequences of it. This is the same thing, just shown in a different form. This is just the inches per year equivalent of water in all the snow from 1950 out to 2100. We've had a slight decline in that over the last decade or so. But as you go out into these scenarios into the future, we end up with a really substantial reduction in how much water there is available in the snow. And this is specifically for the snake headwaters here. So, with no mitigation, you end up almost by the end of the century with almost no water stored as snow in the Snake River watershed. Which again, how do you maintain a reservoir like this in that context? So what we hope to do with our project is really do research on this and take it from this climate that I've just been showing you, these climate scenarios looking at the future, and then think about both in terms of field research and computational modeling, think about how the vegetation is going to respond to that. What about wildfires? What about the streams and rivers? How will they change? And how do those two things together feed into affecting our lakes and reservoirs? And then how do all of those components affect people, our communities, and our economics? And we don't want to, again, do this in isolation. We want to have more opportunities like this where we meet in this room or in other places and discuss this. And we want this to be kind of a continual cycle of iteration where we share with you, like I just did, some of the projections, and then hear from you some of the concerns, and work together to think about the research we need to do to answer the questions that really will help us prepare for these changes in the future. And that's at the heart of our big project that we're going to be that we're launching now, and that this is kind of the kickstart for, and that will really, a big section of that project will be kind of grounded here at the AMK and focused on Teton County and Grand Teton National Park. So I'll just sort of wrap it up here by saying what we're really hoping for, a discussion with all of you. We need to hear Teton voices in our research. We don't want to just be off in isolation. And we want to think about, what are the consequences, and you think about things like fire and recreation and wildlife, but also what are the policy decisions, what are the management decisions that are going to be made, and how we can help explore what those consequences might be. So we'd love to hear your thoughts on, what potential changes are concerning to you, what kind of projections might be useful, what kinds of things could we work on together to help you imagine that future, and what types of choices or policies might be brought to bear to this topic, and we can try to help think about what the outcomes of those might be. So I hope this is useful at the AMK, but also just to help you reimagine what's happening here on this landscape and how it's changing. And with that, I'll stop and take any questions if you have any. Thank you very much.
Yeah, thanks, Bryan. That was a great talk and great introduction to the WyACT. You talked a lot about engaging communities and local communities and stakeholders in the decision-making and how we spend and allocate this money. You also talked about irrigation and the irrigating community down in Idaho owning most of that lake. And so is there any plans to engage with those communities that are much further afield, but largely dictate conditions in the Snake River and therefore conditions of our fisheries and water resources?
I think this is really something that we're kind of grappling with, like how to best handle this, but it's exactly at the heart of the point that it's not just about the physical science of the climate change. I was emphasizing sort of our choices about carbon emissions, but that's at the global scale. Our local consequences are also the uncertainty about the future is really heavily impacted by what the choices are. But again, I go back to that notion that there's all these boundaries where these choices and decisions cross. It's not just what we decide to do right here, but like you're saying, it really is going to matter. Like for this lake, it's really going to matter what people in Idaho decide. And so I think in terms of us envisioning the changes here, we want to make sure that's represented in our sort of scenarios that we're going to work on projecting for the future. So I can't tell you quite what that's going to look like, what that conversation is going to be like, but I think certainly it's going to be an important part of it. Yeah.
Yeah, my comments are questions along a similar line. You showed these projections where the amount of snowfall decreases, the amount of precipitation stays basically the same. And so one could say, hey, we have a dam here, and so we'll catch it in the catchment basin, right? And so whether it comes to snow or rain, will have the same amount of precipitation here on the dam. But then you add in the Snake River Plain and the greater water demands being made by people who had prior use, senior water rights people, and it doesn't matter if we have the same amount of precipitation held behind the catchment basins. The demands downstream are going to be greater.
Yeah, and the other part of it that's also really important to think about are some of the sort of unintended or things that you don't think of necessarily right off the bat. It all seems like it's all water falling, doesn't matter if it falls as snow or rain. But whether snow and rain face different risks of being evaporated back into the atmosphere. And one of the things that's really interesting about a reservoir is, and I think is really fascinating for Wyoming overall, is that depending on how you look at it or calculate it, does anyone know what our single largest use of water is in the state?
Probably recreation.
Recreation is actually pretty significant, but there's like two other kind of answers that are the common expectations. Like, well, if you just thought generally in the U.S., what would we use water for in reservoirs? Irrigation, agriculture is one, and there's actually another one that's even bigger, but doesn't take up water in the same way. It's related to that. It's energy. We use water for cooling power plants, but roughly equal in this state to the amount we use for agriculture or the amount we use to cool power plants is the amount that we lose to evaporation from our reservoirs. So storing the water in a reservoir seems like a great way to save water, but actually is a perfect big pan to let it evaporate away into the atmosphere. And so we actually, to some degree, lose some of our outcomes. Yeah.
I'm just curious if there's any economic impact that's part of the study, or if that could be like an add-on to this, because there's so many implications, not only locally, but even nationally as well. So that's one way to get people's attention. If you say, not only is there less precipitation or there's less snow or however it works out, but that there's this amount of economic devastation that could occur as a result.
So this is exactly why our team involves several people from the economics department, and so we've got a really fantastic group of economists at University of Wyoming who are really interested in some of these types of questions, and I'm excited to work with them to help try to think about it in those terms, because I think you're right. It's one thing for me to talk about it sort of in an abstract environmental sense, but it's another thing to realize where it actually impacts, our economic systems on like really specific ways. Yeah. Chip.
The focus on the reservoir and how that's managed, that's completely logical. It's important to do it, but the percentage of the watershed, 30%?
About 30% is regulated and 70% is unregulated.
Yeah.
So don't be distracted. Don't be entirely distracted by the reservoir. There's 70% of the water that goes into the Snake that doesn't go through the reservoir.
Yeah,
and
exactly.
And what's going on with those systems, and what does that mean?
I think it's going to be a really interesting interplay to consider, is that you have some sectors of the watershed that are managed heavily and some that are not, and how do they play off each other in terms of what the consequences will be. That's a really interesting question. But yeah, go ahead.
Are you familiar with the folks down at UNM in Albuquerque and the Resilience Institute? This was a similar funding stream, right? $20 million over 5 years, and it's about resilience across the West. Some of the co-PIs are tied into ASU and other places. Are you coordinating with these folks? And is there a whole set of these EPSCoR large 5-year grants across the American West, or perhaps across the whole country?
Yeah, well, there are grants across the whole country, and we do have regular meetings where all that science gets shared across districts. But we also have ways in which we're engaging with some of these other things. That we have an external advisory committee that represents scientists thinking about some of these same problems from different institutions, who will help kind of give us some feedback, like you're mentioning, about the success of other programs and what we can do to build on that. But right at the moment, we're not specifically collaborating with some of those other institutions. Although I think you're right that hopefully in the long term that would be a really great goal, because we're all looking at very similar questions and issues across the whole West.
Is there a geographical boundary to your area? Is
There
it just
is.
a GYE?
So actually, our research broadly here is sort of aimed at the whole greater Yellowstone region here through the research station. But this WyACT project is actually specifically bounded to being within Wyoming. So it's an investment in research and contributions of research to the state of Wyoming. So we're really focused on the Wyoming component of it, but we hope what we do here is relevant to people across the West, and that we can share what we learn here with people, say in New Mexico and elsewhere, and that we will in turn learn from them. And it hopefully is a launching point for other collaborations as we go forward. All right, well, thank you so much for listening, and it's just great to have you all here, and hopefully we can have follow-up discussions on this. In September, we'll have a workshop up here that's going to be aimed at really starting some more of these conversations in detail. If you're interested in any of the results that I talked about in terms of climate, you can find the Greater Yellowstone Climate Assessment at gyclimate.org. And otherwise, I will just say it's wonderful to welcome you all back to the AMK Ranch and the research station grounds here. And please feel free to take some time now to see some of the things that have changed over the last few years, if you'd like. And hopefully at least some of us can walk around and look at the buildings and some of the changes, some of the renovations that have been done. So thank you all. It's great to have you all here.